I was not audible. Okay, I was not audible previously. We need to make sure it's audible. Anyways, let's continue. We finished uh, 1, 2, and 3.
Hello, everyone.
So we need to. We did 4, 5, 6, 7. We have to finish. And so far, where were we? Yeah. We need to finish 5, 6, 7.
I'd like to welcome you.
We did this. Actually, we did this. We have to do 8, 8, 9, and 10.
Okay.
That is 1.4.
We're still slogging through the material. Okay.
Alright, where's the copy this and we'll ask what, so based on the text, what chapters, what section chapters exist from here. I'm going to go 3 hours, do 1 or 30-minute break, and then 1 or 30-minute and stop. 1:30. We have introduction to data representations, arrays in memories, pointer arithmetic in C, array indexing and address computation, machine code for arrays, incrementing arrays using assembly, like loops, that. So based on this, we see that these are C programming language. So they use C programming language. Programming language, correct? All right. So can you do me a favor? Do me a favor. For the 14 sections, firstly, label this as section 1.4. What was the book name again? So section 1.4, program optimization and memory hierarchy systems. Yeah, program optimization, memory hierarchy structure. No, it's procedures, memory layers, and low-level data structures. So procedures, memory layers, low-level data structures. Procedures, memory layers, and low-level data structures. And then do the latex code for all the 14 sections. No, okay. No, I meant each subchapter, like, can you, like, oh, okay, like, explain what is going on, easy explanation, so that I understand and whatever, and keep the structure, like, and the mathematics and whatever, including the programming language also, please. Label this as section 1.3, procedures, memory layouts, with the 1.3.1, with the explanation, and, you know, 4 examples. Let's go 4 examples of C programming, and then 1.3.2, 1.3.2 explanation, 4 examples with C programming, and then so on and so forth. This was supposed to be my book, but nope, I didn't do that. Oh, you need to have the beginning document and whatever, right? Need to also have that begin document and 12 PTS, whatever. So, why do you write 1.1? Okay, you kind of messed up actually. And no, we're gonna change the data, don't worry. The other 1.1, 1.2. How do I remove that? I understand why that happens. Okay, that 1.1, 1.2. I understand why that happens. Why that happens. I understand because you have section after section, because you have section after section. So they are presuming that it's bullet points. But is it possible to remove the 1.1, 1.2 and only have 1.3.1, 1.3.2, whatever? Okay, so I have to write, I have to put a star here. Okay, can you modify the entire code then? Entire code then. I'm going to remove that machine level programming notes. I'm going to remove that. All right, look at it. Beautiful. Yeah, leave that. Leave that. Don't worry. Leave that. This is one point three procedures, memory layouts, and low-level data structures. So at the machine level, all data is represented as bytes in memory. A computer does not understand arrays or structures or matrices or objects. The machine only understands addresses plus bytes. The machine will only understand addresses and bytes. C programming language allows us to work very closely with the memory representation. The memory can be represented in the form M of B0, B1, B2, B3. So each byte, so int of x equal to 5, so binary would be 0, so all zeros 101. How do you actually, how do you program this? Like this example, how do you code it? So 1.3.1, how do you program it? How to program it in C? I'm just going to use the online C compiler for now. How would you program it? How would you program the example? Because students would also want to see the the program, like C code, entire one. So include stdio h and then int main int of x equal to 5. So value of x is that percentage d, that percentage d means the integer, and percentage p is the ASCII code, right? The ASCII address. Um, always. So always start with the stdio.h. This is also applicable. So this is also applicable in the C++ code. So can we convert this code? No, wait, one by one. Just convert this code into latex code. Add that here. Oh, oh no, I'm gonna add it here actually. Add it here. So includes stdio int main, then int of x equal to 5. So okay, I understand why that happens, but you know what? Not so value of you understand, right? So value of x would be percentage d, and why do I have those? I know why that happens. I know why that happens because it's a latex code and they don't understand space inside a function, but I don't know how to fix it. That um, uh, uh, U-shaped, that is for space in the code. I know why that happens. I know why that happens, but um, how do I remove that? Because a space is also a character here. No, that's fine, but your space is also a character. So where do I place that? Show spaces. Where is show spaces? No, I don't have any show spaces though. Nope, I don't have any show spaces. So let me show you the code. Let me show you this code actually. Nope, I don't have any show spaces. LST set. Where is? Oh shit. Underscore LST set. Okay, so by default they're saying show spaces is true. I think that's not wrong. That shouldn't be wrong. That shouldn't be wrong because by default they actually set that as true. Okay, now I got it. It's cool, cool stuff. So int of x is binary, so we did that int of x, and then value of x, and the address of x. So address is specifically the memory address that's converted into ASCII code, right? Example 2, 3, and 4. Example 2, 3, and 4. Can we write the C code for this into one program and convert it into latex code? Although I know how to do it, so let's write hashtag include stdio.h int main double by 114 array of 0 being 1, array of 1, 2. Actually, I can save some memory address. Array of 0, 1, 2, 1, 2, 3, then println. Am I doing it right? Okay, printf is how this is. Okay, so select x. So what did they do? So int main and character of C, that's A. So car means character. So let's code it again. So include stdio. Okay, hashtag include stdio.h int main character of E is equal to A. The percentage C is the character, percentage D is the ASCII value. The percentage D is the value, percentage C is the character, percentage dot F, the percent like double value, percentage dot 2F is the real value in uh, two decimal places. So printf binary value. Do you put a comma here? No, it's character. So let's say character percentage CN. That's how you write, right? Percentage CN C. That's how you write. The percentage C N and then C. Then print F ASCII value percentage D N T printf binary value. So A is what? 10. 1, 1, 2, 4, 8. Wait. 128, 64, 32, 16, 8, 4, 2, 1. And how do you return it? Then let's say return 0. We run it. Is it for all of it? Okay, it is for all of it. Oh, because it's the variable is C, not D. Isn't it printf? Printf. Oh, I know why. Boom. Okay, now what? Okay, what's the error here? What's going on? I'm confused. I'm confused. What is going on? Oh, it's a string. I mean, sorry, it's my bad. It's a character, not a string. Okay, now it worked. So core stuff. If it's a string, so 1. If it is a string, then A. If like phrase or no, sorry, double quotation A. As in like apple. And if character, then A. If string, then str. If character, then character. To get value will be percentage %d, and to get character percentage %c. To get string, it'll be percentage %s. String, it'll be percentage %s. Before that, I want to see something. have the highest views, 403 views. Again, I have the no. The double by 3.14. If you want to write a double, let's see. Let's try int main, then double by 3.14. Printf double by value percentage dot 2f by and return 0. No, what? Oh man, this how do you shit? You know what? Okay, I know why. Because you can't have two int mains. Dude, stdio.h. Let's say printf. How do you write the memory address again? Percentage %p slash n. So memory address percentage %p slash n and by. Oh, I forgot to put slash n. Now, how do you write an array? I'm also going to write array of 3. Array of 0, array of 1, array of 2. Again, that's the memory address. We can print the memory addresses. So printf, these are your values. Printf, print first value in the array. Direct percentage, okay, percentage d slash n array of 0. Then you do the same for 1, you do the same for 2. Oh wait, it's array of 3, right? Copy. Array of 1. This will be the first value, this will be the second value, this will be the third value. And printf, these are your memory addresses. Printf memory address for first value percentage %p and an array of 0. Then you can do the same for 1, you can also do the same for 2. This is the second value, the third value. So that's array of 0, that's array of 1, that's array of 2. Oh no. I think the only reason is because we have... Did I make a mistake? Okay, I'm missing a comma somewhere. Okay, yeah. Now, what am I missing? Did it? It didn't appear once. Really? Oh, yeah. No wonder. There you go. There you go. Good stuff. Arrays in memory, so core ideas. So arrays are stored in contiguous memory locations. So if n being the number of elements and k being the data type size, then the total memory required is n times k. And if a being the base address, then address of ai, then a absolute value of I would be a plus I times k. So int of array is 5, so each int has 4 bits, so 4 bytes. So 5 times 4 is 20, so you're going to have 20 bytes in total. So actually based on all those, what's the... So based on this core and whatever, like what's the core syntax? One must know, like percentage d, percentage n, percentage c, like that. So based on this, what's the core C programming syntax? One must know. Like for character, it is percentage C, or integer, it is percentage D, whatever, like that. Convert all those into latex code. Please, can we raise? I beg you. That's the core. So these are core. Okay, did we miss? Nope, we made a mistake, right? Because that end listing was inside the box. So core C format. So printf to tell C what data types are being printed, how the value should appear. Percentage C used for character. So character of C is A, and printf percentage C, and then it's going to output A. And then integer would be percentage D, float specifier would be percentage F, double specifier. What the fuck is 14,000? Where did 14,000 come from? 14,000? Oh, 3.14. Okay, 3.14000 because percentage F. So it's going to output literally all the values. So we can actually write 3. Although in reality you are only going to have 3.140000 because the value literally mentioned 3.14. So but here percentage F has no limit as to how many decimal points you want. How many decimal points you want. And double specifier. So that will be percentage. Wait. Percentage 1F. So you're gonna have 3.141590 there. Let's do. You know what? Leave it. If you have percentage, what's percentage 1F? Oh, percentage 1F means 3.141590. If you have percentage 2F, then you're going to have 3.141590. If you have percentage dot 2F, then you're going to have 3.14. And then string specifier, pointers. So x equal to 5. So you're going to have pointers is usually used for memory address. Hexadecimal percentage x, that's usually used for hexadecimals. Uppercase, so percentage x, capital X. So if you do that, you're going to get the hexadecimal in uppercase. And unsigned integers, so percentage n. So if int of x is equal to 42 and printf percentage u, so output will be 42. And means it outputs the address, so you can literally see the full address, like the memory location address. Pointer is star, so int star p. New line character, double new line, so 2 spaces, and then decimal precision. So if you have 3.14159, and if you do percentage dot 2f, you're gonna have 3.14. All right. Let's do 1.3.2. So the core idea is that arrays are stored in contiguous memory locations, and if n being the number of elements and k being the data type size, then the total memory required is n times k. So for example, the address formula, so if a being the base address, then a of I would be a plus I times k. So let's say, for example, int of array is 5. So obviously each integer will have 4 bytes, character will have 1 byte, double will have 8 bytes, address, like base address, like if you want to find the memory location address, they're going to have the base address being 1000. So for example, if you have int of array is 5, so 4 bytes, now you're going to have 5 values, obviously. And because you're going to have 5 values, 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes. Each space for an integer will have 4 bytes that's covered. So 4 bytes covered, 4 bytes covered, 4 bytes covered, 4 bytes covered, 4 bytes covered. So you're going to have 20 bytes in total. and character of name being 0. So name 10. So you're gonna have 10 characters of a name. So each character is 1 byte. So you're gonna have 10 bytes in total. Can we do a C programming language for this? Although I know how to do it. Can we do a C programming language for this? Wait, isn't there 14 chapters? Why is there only... Okay, can you repeat again? Like... Wait, how many chapters are we doing again? Before that, we are doing 14 sections, right? So when you look at the code here, based on this latex code, how many sections are covered? Okay, we're gonna add them, don't worry. Yeah, we're gonna do them. Okay, then can you add the 1.3 okay, is it possible to... No, it's fine. Possible to add the latex code explanation for 1.3.5 to 1.3.14. I understand why you did for first 4, because I was the one who said it. I was the one who stated to do step by step, but add all the remaining from 1.3.5 to 1.3.14. Pointer arithmetic in C. So pointer store addresses. So pointer arithmetic automatically scales by data type size. So if P is pointer and data type size is K, then P plus 1 is equal to P plus K. For example, if integer of star P, then P plus plus, then since int has 4 bytes, then pointer increases by 4. So pointer initially is 0. Okay, so what happens is that P plus 1 will turn to P plus K, whatever the K byte is. So if I have int of star P, so int of star P, then I'm going to have, let's see, int of include stdio.h int main. Then if I have int star P, P plus plus, I have P plus K, so I have 4 bytes now. So P will now increase by... Okay, so can we do an example like where it actually... I know pointer increases by 4, but is it possible to see this in a live action, like we do the code with the renaming in variables and whatever? I understand what's going on here. I understand what is going on here, but is it possible to see like an actual example that where the 4 bytes are actually increased. So array 1 will be 1004, array 2 will be 1008 because you increased by 4 bytes. So I can actually copy this. No, I know. Copy that. Oh, wait. Convert this to latex code actually. It should be like, oh shit. Select all. You're gonna have initially it's that, so whatever the address that is. So initially it'll be 1000, but then after the first step, so instead of 1000, 1001, you're gonna have 1000, then 1004, then 1008, 1012, 1016, and whatever. So this is. So if I were to actually convert this into latex code, first of all, convert this into latex code. Convert whatever you just explained into latex code. So the code, the full real example and what happens and stuff. Full real example and whatever you explained just now, for the pointer address, star p and p++ with the C code. Can you convert that into latex code? Does it start from core idea or does it start from example? It starts from core idea. So actual pointer arithmetic. So the core idea is that the pointer arithmetic does not increase by 1. Instead, C automatically scales increment using the data type. So the important formula is that p plus 1 will be p plus k, where p is the pointer address, k is the data type. So let's say, for example, int main and then int of array. So we can have 3 spaces, so 10, 20, 30. And now the percentage of p will be the array. So percentage of p is the memory location for each. So we're going to do the memory location of this, memory location of this, memory location of this, right? So initially what we will do is like whatever the so array of 0, which is 10, is located at 1000 initially. So suppose the memory layout is 1000, 1004, 1008. So what it's going to do is p of 1000, which is value of 10. The p++ would add it by 4 because int has 4 bytes. So you're going to have 1004. So instead of 1000, 1004, 1008, because we added by 4, and the only reason we added by 4 is because the int is plus 4. So you're going to have 1004, 1008, 1012. So finally you're going to have, oh wait, yeah, 1004, 1008. Where is 1012 though? So okay, p is 1000 initially, so pointer reference array of 0. So C automatically increases the address by 4, so 4 bytes. So new address will be 1004. So array, now pointer references to array of 1. So it's going to be 20. And then C p++ again 1004 plus 4, 1008. It goes to 30. Why didn't we have 1012 though? Why didn't we have 1012? Yeah, write this in LaTeX code. Write this in LaTeX code. Because I want to make sure that students thoroughly understand what's going on. Because the questions I'm asking, probably because this is for everyone. So why did we not reach 1012? The pointer only incremented twice, which is 1000, then 1004, 1008. Each integer occupies 4 bytes, and this. Let's recompile that. After 30, there. So, however, array of 3 does not exist. You only have array of 0, array of 1, array of 2. Because array of 3 creates 3 elements. If you want to have 1012, you must have 4 elements. This may cause undefined behavior, memory corruption, segmentation fault, security vulnerabilities. I think it's the same for all the other ones. It's the same for all the other ones, because although is it necessary to mention? I don't think it's necessary to code it out. But it's the same thing. Like, it depends on, like, okay, double is 8 bytes, so you're gonna have 1000. So if you have, like, let's say, actually, how do you do that? Can we do character? Yeah, can we do character example in C code if that's all right? Can we do one C code for character? Can we do one C code for character? So A, B, C, then character of star C would be letters, the initial address. Can copy this code. I'm also going to warn them that this C++ is not the code. I'll warn them, don't worry. Letters, address. So here, warning, this C++ is not a coding language, but to increment the byte size based on the character byte. So it is P plus K. K for being byte size, and for character it is 1 byte. Okay, there you go. So warning, this C++ is not a coding language, but to increment the byte size based on the character byte. So it is P plus K, K being byte size, and for character it is 1 byte. So you're gonna have P plus 1. Array indexing and array computations. Core idea is that array indexing is secretly pointer arithmetic. So formula would be A of I would be star of AI, A plus I. So array of 2 would be star of array plus 2. If you have array of 4, which is 5, 6, 7, 8, and array of, suppose array of 1000, so array of 2 will be 1008, because 1000, 1004, 1008. Okay, can we do one coding language, one programming language to understand it better? Can you write the C code? I just want to understand what's going on. Is it possible to write the C code? I just want to understand what is going on. sorry. We're gonna write the entire code here. The full array, so int main array of 45, 6, 7, 8. So using the normal array, just normal array. The percentage d, so you're gonna get the value, and then the pointer arithmetic, you can have array plus 0. Actually, let's run the entire code. Why not? Let's run the code. So obviously 5, 6, 7, 8. So using the pointer arithmetic, then you can have also 5, 6, 7, 8, but the memory location will change. Why does it? Okay, yeah, using the pointer arithmetic. I'm curious, why does the pointer arithmetic, why will the pointer arithmetic output the same values as the normal array indexing value? Oh, are literally the same operation. Ah, they're the same thing. So, you see, suppose you have array 1000, then int is 4 bytes. So memory becomes 1000, 1004, 1008, 1012. So array of 0, this page number. So array of 0, it will be array of, so star of array plus 0, so 04, which is 0. And then you're going to have 1004, and then you're going to have 1008, and then you're going to have 1012. So this is the literal core equation, star of array plus whatever the position value is. Yeah, I understood. Here's a watch my come back. access pointers, convert it to names, convert it into index or easier. So arrays and pointers are closely related, but they're not identical. So array is a fixed memory block, while pointers are variables stored in memory. So understanding the array, so int of array immediately allocates a memory. So it's like, like there are no values input yet. So but the memory location is the address 1000, 1004, 1000. What are the values? So we don't know what the value will be and address 1000. We don't know what the value will be and address 1004. We don't know what the value will be and address 1008. So the array itself is the memory. And now we want to understand the pointers. So int star of p does not create an array, it only creates a variable storing an address. So the pointer itself exists somewhere in the memory. So this address of 1000 pointer is, so it's going to like draw an array, arrow, array, arrow, arrow, arrow. Block is there, but the arrow, right? Where is the arrow stored? We don't know that. Because this is like an arrow, basically. So think of this. Think of pointer as an array, arrow. Although address is set, we don't know where the pointer is pointing at. Pointer slash arrow is pointing at. So now we have, so now the pointer is array, so now we are addressing, okay, the pointer should go there. So each integer has 4 bytes of 12. So the size of array will be 12. The size of pointer is stored one address on 64. So the size of pointer will be 8 because it has 8 bytes. Because usually pointer is stored one address. On most cases, one address is a 64 bit. A 64 bit is complex array and one array declaration. So C allows complex combinations of arrays, pointers, functions. Int. This means that the pointer will point towards an integer. So int verifies an array of pointers. So you're gonna have let's say 5 values. So you're gonna have value 1, array, arrow, value 2, arrow, value 3, arrow, value 4, arrow, value 5. So that int, so it's like a literal. So the first one, where this is the number of arrows. This is, so string value 0, this is value 1, value 2, and so on. Array containing string pointers. So character of length 3, so you can have S, A, multi-dimensional array. So core ID is the 2D arrays are stored row by row in memory. This is called row major order. The matrix of 3 will have 0, 0, 0, 1, 0. 2 rows, 3 columns.